Okay, so today we're going to talk a little bit about quadratic models. So we're going to quickly go through the standard form and all things that should be reviewed from Algebra 1 and Algebra 2. So hopefully by now you know that the standard form for a quadratic is y equals ax squared plus bx plus c. So that's how we're going to use our quadratics in this unit, and so we should hopefully know by now that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to have to use those two things throughout this section of the textbook to form some models. So the vertex is either the max or min point. And we can find the x-coordinate of it by having negative b over 2a. And then you can always find the y-coordinate of it by plugging that x back into the function, so f of negative b over 2a. So we'll do some examples of those in class. So that's actually how you find the vertex, so that should go down there on the screen. Okay, so we want to consider this function, f of x equals 2x squared minus 3x minus 2. So first we want to find the x and the y-intercepts. Well, for y-intercepts, that is when x is equal to 0. So the easy way to find that is just plug in 0. So we do f of 0, and we get 2 times 0 squared minus 3 times 0 minus 2. So we get negative 2. So our y-intercept is the point 0, negative 2. So x-intercepts, you actually have to solve your quadratic. So for x-intercepts, we set it equal to 0. And we solve for x. So I'm going to use the quadratic formula just for a little review. So we're going to have x equals negative of negative 3, which is positive 3, plus or minus the square root of b squared is 9, minus 4 times 2 times 2. So we get plus 16, all over 2 times 2, which is 4. So 9 plus 16 is 25. We know that the square root of 25 is 5. So we get 3 plus or minus 5 over 4. So if we do the plus, we get 8 over 4, so x is 2. If we do the minus, we get negative 2 over 4, which is negative 1/2. So our x-intercept are the points 2, 0, and negative 1/2, 0. So hopefully all of those skills you kind of remember from Algebra 2. And so then we want to know if this function has a minimum or a maximum point. So if we look back at the a value, it's a positive 2, so we know that our parabola is facing up, since a is positive. Which means we have a minimum point. So to find it, we're going to do that x equals negative b over 2a. So we have negative of negative 3, it's positive 3, 2a was 4. So we have the x-coordinate is 3 over 4, so then we're just going to plug in 3/4 to our function. So we get 2 times 9 over 16 minus 3 times 3 over 4 minus 2. So if we do some fraction work, we get 9/8 minus 9/4 minus 2, which is going to be equal to 9 over 8 minus 18 over 8 minus 16 over 8. So just doing the arithmetic, we have 9 minus 18 minus 16 on top, which gives us negative 25 over 8. So our minimum point is at 3/4, comma, negative 25 over 8. Okay, so now we're going to talk about how to use known quadratic models to find the height of an object after it's been thrown. So you know if you throw something, so here's you, and you throw something, let's give you 2 legs, it travels in the shape of a parabola. So like if you throw a basketball or anything like that, that's how it moves. So we have this known model that says the height of an object after time t is equal to negative 1/2 times gravity times time squared plus your initial velocity times time plus the initial height. So let's just write out what all those variables mean. So t is the time after the object is thrown. G is gravity, and so gravity has two possible answers. It depends on the units. So gravity is either going to be equal to 32 feet per second squared, or it's going to be equal to 9.8 meters per second squared, all depending on the units of the givens that you have. We say that v with the subscript of 0, we call that v naught. That's the initial velocity of the object. And h naught would be the initial height of the object. So we're going to do an example to show you how this kind of works. So in this example, we have a ball is thrown upward from a height of 15 meters with an initial velocity of 20 meters per second. So that tells us that h naught is 15 meters, v naught is 20 meters per second, and since v naught is in meters, that tells me I have to use gravity as 9.8 meters per second squared. Okay, so we want to find the relation between height h and time t after the ball is released. So that means we want to write the model. So we're going to just plug in our constants. So we have h of t is equal to -1/2 times the gravity constant was 9.8 t squared plus 20t for our initial velocity plus our initial height of 15. So if we simplify -1/2 times 9.8, we get -4.9 t squared plus 20t, all plus 15. Okay, so that's the answer to part A. So in part B, it wants to know how high is the ball after 3 seconds. So all we have to do is find h of 3. So we just plug in 3. So we get -4.9 times 3 squared, which is 9, plus 20 times 3, plus 15. So doing some calculations, we're going to find that, let's see, our final answer should be 30.9 meters. And so remember, since this is a word problem, we definitely want to put our units on. And then part C, final part to this problem, we want to know when will the ball hit the ground. So the ground is at height 0, so we want to know when this equation is going to be equal to 0. So this is a great way to use the quadratic formula. So we're just going to plug and chug into that. Give us some more room. So we have that t, since our variable is t and not x, is equal to -20 plus or minus the square root of 20 squared minus 4 times -4.9 times 15 all over 2a, which is going to give us -9.8 in the bottom. So let's go ahead and simplify. So we have 20 squared minus 4 times -4.9 times 15 under our square root, which is going to give us 694. Okay, so if we take the square root of 694, we get that it's approximately 26.34. So we have -20 plus or minus 26.34 all over -9.8. So now we have to remember that our variable here is time, so we have to only use time as positive answers. So if we add -20 and positive 26.34, we're going to get a positive number in the top, but then we're going to divide by the -9.8 and get a negative answer. So in this case, we only want to look at the minus answer, so we're going to get -20 minus 26.34 all over -9.8. Using our handy dandy calculators, we are going to find that that is equal to 4.73 seconds. So if you were to throw this object with these initial constraints, it would take approximately 4.73 seconds to finish landing it on the ground.